Hi everyone, today we are continuing our video which is about the possibilities and their importance at the systems we are investigating. So in this video and at the end of this video you will be able to understand and also see how important they are and how they are working. At the systems, as I said, we will be able to understand again the quantum mechanics. We will investigate the wave equations and demonstrate the Schrödinger equation, which is time-dependent and not time-dependent. So maybe at the end of this video we will be able to talk about it. But now I'm going to talk about a little bit possibilities at the smallest dimensions, like a quantum mechanics and the atomic structure. Yes, we know that the orbitals, the nucleus, or maybe inside of the nucleus, they are the conduit issues to talk about, yes, but there are other suggestions and solutions interrupting our system, and these are the mechanical physics and the modern physics. Not mechanical physics. We will be continue and also discuss the events which are visible and which we are observing with the modern physics. And soon afterwards, after an assessment which is done by us at the end of this video, we will be understand and demonstrate the possibilities with the equations in physics, like a wave function and the time-dependent equations, amplitudes, or maybe the wavelengths, something else like that. So yes, that will be a little bit interesting video for us. But as I said, the equations will be in the video at the end parts, okay? Not that time. Just right now, maybe it will take 5 or 6 minutes to continue with it and talking. Just we will investigate the possibilities and the importance of the quantum mechanics. Why are they important at the quantum mechanics or the smallest dimensions? The subject is that. Why are they important? Because in the previous video I said, and maybe you have observed, I said, yeah, at the smallest dimensions, like an atomic structure, the electrons, protons, or anything else that is so small, like a 1 nanometer and smaller, you know that, the particles have a motion, yes, of course, but this motion has a value like a kinetical energy, the potential, and they have the velocity which is near to the light speed, which is the best thing that awaits us, that we cannot determine anything else easily. Like we are observing and we are doing our experiment, but they are acting like opposite of our acknowledgements. So yes, we are shocking. Oh, how is that happening? Because they acted like we did not expect, so to speak. Oh yeah, we need the other laws, which is about the modern physics. At the end, not at the end, sorry, I said the electrons are, honestly in this video we will investigate the electrons, not the deeper or smaller particles, because they are more complement, so to speak, complicated, I mean. This is why that will be a lot of time, and I have no time that much because for uploading that video to the YouTube or towards the YouTube. So yeah, we will talk about electrons only, but you will be understand how important the possibilities at the electrons too. Because if you know the possibility, you can easily, or maybe not easily, okay, you can easily say, or maybe say that it will be there or it will be act like that. So our admiration towards the system is going to be clearer than the classical mechanics. In this way, yes, what I intend to do is investigation of the motion of electrons with the possibilities. I say if the electrons are moving like a circling around the nucleus at the speed of light, not at the speed of light, smaller, but the value of the speed or the velocity is near to light speed, which is causing that the uncertainty principle. You cannot deduce easily where it is, or the energy level, which is time dependent. Or maybe if you know the momentum, you don't know the place, like a location or the orbital, where it can be. So to speak, you are using the Heisenberg's equation with time-dependent equations. At that speeds, they are, for example, you are doing an experiment towards a system like an atom, and you say that, yeah, it's there, and nothing is going to be certain. This is why this is going to be happen. Sorry. Okay, we are. Yeah, there is now sound which is allowed and not disturbing. Not disturbs me right now. Okay, good. What I said, the electrons, of course, they have the value of speed, which is near to the light speed. So it is not easy to determine how they are acting, as I said. And we are using the possibilities because the particle which is orbiting at the nucleus near to the light speed as a value of speed, it can be everywhere. For example, for the t1 time, for example, first time you are observing it in here, honestly this is just an imagination, not true, okay? Not true, just imagine, like improvisation, okay? And the second time when you observe it in here, okay, so there's an import which is angular, but oh, how much will you continue with this observation? It will not easy to understand how its orbits is going to be changing, because not easy, this is not the value that we can observe easily, just we can investigate the eventualities and the other results of our experiments, because maybe the electron affected by the light like a radiation, and this is why it changed its orbital, which is the higher level, which energy. So yeah, this is important to investigate. As I said, for the quantum mechanics, if the particles are moving and rotating around the circle and around the nucleus at the speed of light, not light, near to light, you cannot deduce anything easily. Or maybe for the just hydrogen atom, just one electron, we know, maybe that will be easy a little bit, but the other elements, what do you say? They have more electrons, so everything is going to be changing. The physics laws, in fact, is going to be interchangeable as time goes on. So everything is going to be well. So let's see how important.